All right, guys, let's keep going. We talked about the scalar version of Coulomb's law. We talked about units. You guys can handle the vector version, so that's what we're going to get into in this lecture. Okay, so the vector version of Coulomb's law, of course, is just a little bit different than the scalar version. And right, with the vector version, we are just going to also consider, oops, I can't spell, the direction of our resulting force around a charged object. Okay, so let's just go ahead and write it out. Our force is a vector, okay? In your book, you might see, right, vectors being indicated by bold. In these slides, I can't really write in bold, so I'm going to try to use the vector sign. I may occasionally forget. You can tease me for it later. Okay, so there's our constant in front. We're going to get rid of those absolute value signs around the charge because now we want to actually consider the sign of the charges. Okay, and then down here, okay, we've got our script R, which is a cursive R. Killing me. No one writes cursive anymore, and I am not an exception to that. So I've been working on my cursive R's. Hopefully they look okay to you guys. And then we've got our unit vector R. Okay, so I said, right, you guys can handle this, but there's some complicated stuff a little bit in this vector form of Coulomb's law, which is why I just wanted to start out with the scalar version. So let's go through this bit by bit. So this right here, you guys should be okay with this. This is the force, right? It is a vector, okay? It can be this value that you calculate, positive or negative. Oops, I guess I can just write negative sign. Okay, and basically what that's telling you is it's giving the direction of the force vector relative to either our r vector or our r hat vector. Okay, both of those vectors have the same direction. So if the force vector is positive, it's in the same direction as the r vector. If the force vector is negative, it's in the exact opposite direction. Okay, so just to give you guys a better idea of that, we'll just go ahead and draw this in different colors. We'll draw a picture down here of the charges. Okay, the big Q. Our r vector, this is important. Okay, I'm going to draw it down here. This is our script R, okay? What the r vector is, okay, it's a vector that always points, this is important, okay, don't forget this, always points from the source charge, okay, to the test charge or the charge that you're trying to understand the force on. Okay, so if you flip that, you're going to get the exact opposite direction. Okay, so let's just think about an example here. If we have two positive charges, okay, hopefully you guys remember two positive charges repel one another. So in that case, if they were positive, you would expect to have a positive force here, positive force vector, which basically this equation works out so that the force then is in the same direction as the r vector, okay? Not the same length, okay, but the same direction, okay? This is assuming, if Q, well, and Q are both positive or negative. Okay, positive or negative in this particular example. Okay, so R is our vector that always points from the source charge, okay, to the test charge. What we have down here, this bit, okay, again, those absolute value signs means that this, what we're putting down here, is the scalar distance or the magnitude, the length of that r vector. Okay, which always points from little q to big Q. Okay, this right here, that little hat, hopefully you guys remember this again from some other class. We definitely cover it in the 180 series. This is a unit vector. Okay, so that means it has a length of 1, okay? It has a length of 1. But the fact that it's r unit vector, okay, that means that it points in the same direction as the r vector here, okay? So r hat points in the same direction as the r vector. The difference is let's see if I can write that, r hat, okay? It has a magnitude of 1, I'll write that again, and it points in the direction of r. Okay. All right, so if I look at this here, okay, what this Coulomb's law, what this unit vector is allowing me to do is down here, because I am taking the magnitude of this vector that is connecting Q, little q to big Q, because I'm just taking the magnitude of that vector. This part is not going to be a vector, right? This part's not going to be a vector. So this r hat, this unit vector, is basically turning the quantity on your right-hand side of the equation into a vector quantity. You don't want to change the magnitude of the vector with our r hat. You just want to give it a direction. So this part is determining the magnitude of the force, okay? And the unit vector is giving you the direction of the force. Okay, so again, this particular form, when you look at it, it looks a little harder than what you guys saw in 183, but it's really not that much harder if you remember what a unit vector is.